guys, welcome back to my channel. This is the first actual episode from where we start learning Java 8, and we are on Java 8 series. In this series, we're gonna talk a lots of thing about Java 8. So let's start with today's agenda. Okay. So today's agenda is to learn Lambda expression, the first feature that Java 8 provides. Okay. So I created few major points in Lambda expression. We're gonna go one by one and understand what that point is saying. Okay. So first thing is Lambda expression is an anonymous function. Anonymous function means a function who doesn't have name itself. So if you are familiar with Java, there is already one feature called anonymous class, a class which doesn't have the name itself. So the same way, anonymous function also brings in Java 8, that is a function without name itself. So that is Lambda expression. This is nothing but a parameters. This is a arrow and this is a method body. So if you see, two things are missing: name and return type. Now, Lambda expression helps in writing clean and concise code. So let's understand why example. So if you know about thread class in Java, so this is one of the way to create a thread. So no worries if you don't know what is thread and how we can create a thread, what is multi-threading and all the stuff. Soon I'm going to create a series on this too also, because that is also one of the most demanded core feature of Java that we need to have understanding of it. Okay. So let's come back to the code itself. This is one of the way to create a thread in Java using a runnable interface. So if you see, there is 1, 2, 3, 4, 5, and 6 lines of code is required to create a thread. A simple thread would do nothing, just print a message called do something. Okay. Now, with the help of Java 8, we can convert this 6 line of code into a single line. How? So, same way. I'm going to create a thread. Now the constructor, if you go inside the constructor, it is asking an object of type runnable, and runnable itself is an interface which have only one method, run. So what we did here is we created an anonymous class. So what it will do, it will create an object of this interface itself, runnable interface itself. Now, same way we need to create a runnable interface object, but with the help of Lambda expression. Here we are using create object with the help of, and now name is class, and now we're going to create object with Lambda. What I said earlier, I'm going to convert this 6 line of code into a single line using Lambda. So this is one of the core feature of Lambda. It helps you write code in a clean and concise way. This syntax you need to remember it. Okay, you have to know Lambda syntax. How it is doing the things behind the scene, we get to know in a moment. Okay. Now, first thing is anonymous function. We know it. Now, how it helps in writing clean and concise code, we just shown with example. This is one of the example. There are many more examples are there. Now, helps in parameterizing the behavior. This is the important one. So in the introduction video, if you remember what I said in Java 8, what is the major change that Java people did? They make function as a first class citizens. Class citizens means function can be passed around. Function, what is function? Function is a behavior. So if you have a class, if you have a object of that class and that object has method, that means it has some behavior. We can pass the function or we can parameterize the behavior. These are the two common interchangeable words that I'm going to use in this whole series. So, okay. So how we can pass function. So this third point is nothing but we need to see how we can pass a function into another function. So if you see, this is the same example. If you see, this is a function itself, although there is one special name given, that is constructor, but at the end it is also a function or method. So here we are passing the object, and before Java 8, objects are the first class citizens because they can be passed around. Okay. So if you don't see it in that way, so let's create an object itself. The same thing. I'm just gonna cut it and then just gonna paste it. I'm gonna pass this object. Okay, cool. So if you see, object is passed here. Okay. And we can do it before Java 8 itself. But after Java 8, we can pass function. So what is lambda? Lambda is if you see, lambda is an anonymous function. And this anonymous function, right now we are passing into a function itself. So this is parameterizing the behavior, parameterizing the function. There are more couple of things about it, but yeah, at high level, this is what Java 8 provides. You can pass one function into another function. Okay. So you had a taste of how passing a function to another function looks like. Let's move ahead and solve a problem. Then we're going to learn more about parameterizing the behavior, what it exactly means. So what is a problem statement is, given a list of data set, filter the odd and even numbers based on input. This is a problem statement. So you have data set is given. What is given is, so let's say now you need to filter the odd and even. Okay. So in the brute force approach, what we can do is we can take an input. So let's consider we have given an input and we're gonna iterate over this data set. And if input is even, then filter even values. How are we gonna filter even values? So if my num is divided by 2, and when we are doing modulus, we should get remainder as 0. Then this is an even number, so we're going to print this number. And when the input is odd, so the same thing we will do, but with a not equal to, because in that case, if you divide some odd number with 2, you're not going to get 0 as a remainder. Cool. Let's run it and see if we are able to get the integer equal. Okay, we get the even. Now let's test odd. Cool. Now, if you see, all the codes are written here only. So this is not a good way of writing a code. So what we can do is we can extract it into a method itself and say print odd or even. And we're going to take this input here. Now we can pass this way. Let me print dividing line. Cool. Now we are able to segregate our data set based on the input. So why this approach is better than the previous one? Because if you are doing coding, so you just need to make sure one thing: function represents some behavior. Function should have their own dedicated behavior. Function should do only one thing at a time. Cool. So in this way, we can make use of this function in some other places also. Okay. Till here, our life is good. This is the way we code right now. So now, how to think in perspective of in terms of Java 8. So we will start from now itself. Okay. So now this input is nothing but a case. A case is even or odd. Now, in some case, so let's say if they ask you to filter the list based on prime numbers, filter a list based on Armstrong number, or something else. So the case, with the growing demand of the business, case will definitely will be increased. Your PM will come and ask for the change requirement again and again. Okay, this is what the way we do coding now and then. Okay, in our companies. So whatever we write earlier, it might not work in the future, or it needs to be updated. Okay, so how we can write code now itself so that we need to do minimal changes in the future. So our code should be extensible enough so to acquire new changes with the minimal effort enough. There is one scenario. What if number of inputs will keep on increasing? So one thing is we keep on adding this else if cases. That is the one thing. But that will be too verbose. Then a lots of if else conditions are there. Now, what will be the problem? Problem is, if the same case, so let's say I ask you to filter a data set and get the prime numbers. Same scenario can come with different data set, different change requirement. Hey, this is my data set. Filter the prime numbers. from the different data set. Now then, again we need to write the methods and all. So now with the increase in demand of business, there will be new requirement changes. So now what PM is saying, hey, you are doing filtering based on the inputs. Same functionality I need somewhere else. Then in some other APIs and all. Then you end up writing the same code to different place itself. Not a completely same code, but yeah, some at some extent. So there, this passing the method itself comes into picture. So isn't it good? This is nothing but a case. This is nothing but a behavior that we need to implement here. This is a behavior. So isn't it good we pass the behavior itself so that this data set can be filtered based on the behavior we pass. Sounds good. So how? So what I'm going to do here is I'm going to represent behavior as an interface. So let's say even behavior. What I'm going to have is int filter. Then what I'm going to have is odd behavior. Now, what I'm going to do here is full. So we need to pass the behavior itself. Now the behavior is filtering the data. That's it. We are just filtering the data, even or doesn't matter. Behavior is filtering the data. So filtering is the behavior filter a data set. So it's gonna get some parameter and it's gonna do some filtering and it's gonna return. So let's say it's gonna return Boolean whether to filter or not. Now, instead of passing this input, let's pass the filter itself, filtering. Now, what I'm gonna do here is if filter dot filter now, then just bring that number. See, from the earlier way of writing a code, this is much more cleaner. Now we are passing the filter behavior itself. How we gonna filter is the behavior, okay? But how we going to do the filter? What I'm going to do, since it is expecting a function, so I'm going to make use of lambda and give a filtering logic itself. So what my lambda expects a num. If this num divides by 2, it's just gonna return it. Same thing. Cool. So we pass the behavior itself. So we didn't write the behavior inside the method. Instead, what we did, we passed the behavior itself. This is what behavior parameterization is. So we parameterize the behavior. So if we're gonna run this application, so this is going to give me same thing. So if in future, so let's say there is one more case where I need to print a multiple of 2. So what I'm going to do here is I just pass the behavior what I want. What I want is if a number is multiple of 3, print it. That's it. So if you see, if we parameterize the behavior, one thing is we return clean and concise code. This is looking good. And at a runtime, we can load this method with different behavior itself. So first time we are loading this with even one, then odd one, and then the multiple of 3 and bunch of other things we can do. Now, why this is the better approach than the previous one? So answer is simple. If a new case come here, you need to keep on adding it. So the original logic is keep on getting changed. Okay. Instead of which, what we did, we didn't touch this one. We only keep on using different types of versions of method. Okay. So we have data set, we pass the behavior. Hey, perform this behavior on this data set. Hey, perform this behavior on data set. Perform this even behavior on this data set, or behavior on this data set, and multiple of 3 behavior on this data set. So my original method is intact. I didn't touch anything here. I just written one line of code, and that is also I just call that function with the required behavior. I get the result. So if you are experienced software engineer, there might be case when you are writing something. So one of the scenario that I came across in my current company is there is already one legacy method was written which is doing filtration on some of the field of a object. And now the requirement is extend some functionality and do the filter on the different field itself. So I had to choose two choice. One is to go and add in the same method itself, okay, with some bunch of if else and then make the code look messy. Or what I can do is I can create a whole new method itself and pass the behavior from the outside. That how we're gonna sort it. So I choose the second one because in that case, in the future requirement, nobody needs to touch the original method itself. Okay, they just need to call that method with some different parameter. That's it. With some different parameterization. That is the benefit of the behavior parameterization that we can get. Now, there is one question you can ask: why this lambda? Cannot we use anonymous class? Yeah, you can use it. But if you use this anonymous class, it will be too verbose. So why to write this all bunch of 6 line of code when you can do in one line of code? Isn't it clean and concise and looks beautiful? Well, no, let's move ahead. So some examples of parameterizing the behavior is, so let's take an example of Maggie's. Why the Maggie company itself put all cheese and sauce and bunch of other things in the same masala and give it in some wrapper inside this and that you can use. They can do it, no? But there will be some people who like sauce, who doesn't like sauce, who like cheese, who doesn't like cheese. So instead of us right deciding it, let's make the people who is going to use decide. Okay. So what is the bare minimum thing is required? I will do that, and whoever calling this method or function will need to pass the behavior. Let's say I'm cooking Maggie and I like cheese. So from the outside itself, I put some cheese. If my friend is wants to eat Maggie and he likes sauce, he can put it from outside itself. A car with different modes: eco, sport, city. So those are given to the driver itself, who is the caller. Okay, you pass this behavior, you pass this behavior, and my engine will start behaving in that way. That is the power of parameterizing the behavior. So Java 8 basically takes an example from the real world and implement in the Java 8 version itself. Okay. Even the juicer machine, we cannot make one juicer machine for orange, one juicer machine for mango, and one for apple. So we need to have one juicer machine where if we give it orange, it will behave like an orange juicer machine. If we put it mango, it will behave as a mango juicer machine. If we put it apple, it will behave like that one only. Same way, if you put it in sport mode, my car will behave like a sports car. If I put it as city, it will behave like that it was in city. So same way. Okay. Based on the behavior, it will work. So functionality wise, nothing actually changed, but the representation wise, it is changed. Same thing you can achieve by anonymous function as I shown here in the code itself, but that will be too verbose. Consider these three cases. There will be three anonymous class. So let me just show you a glimpse of it. How it gonna look like. So is it looking good? Definitely not. No. No, Lambda expression has three parts as I explained here. It has parameter, an arrow, and a body. Now, if you did you know the difference about statement and expression? So, if you know about a statement and expression, do let me know. I will explain in comment. It is a fair, simple, basic thing. You can even search in Google or also you will get an idea. Okay. Now there is some example of the valid and invalid lambda. So if you have nothing to pass parameter and if you have nothing to return, then this is the way to do it. If you have some parameter, some of its field, if you see there is no return here, but still this value is getting returned. So that return is kind of hidden. Now, there is one more thing where we have one parameter and we are printing its name. There is no return and all, but sysout doesn't return anything. So it will give some error. So that's why I said statement and expression you need to understand this lambda expression, when to allow this type of syntax and when this type of syntax will work. So if you see this, these two syntax, there is only few changes based on visual, but major changes are behind the scene. Here it will return, here it will try to return, but it will get some errors. Okay. So the next concept that we need to talk about is type checking. So what I said earlier is Lambda is an anonymous function. There is no particular return type, there is no particular method itself. Okay, there can be question in interview, then what is the type of Lambda? So let's say the type of Lambda depends on the functional interface it is implementing. So the type is identified by the context in which Lambda is getting used. Example, method parameter that it's passed to, or the variable to which it is assigned, known as target type. So Lambda target type is nothing but in which context Lambda is used. That is the type of Lambda. So here, what is the type of this Lambda? So the type of this Lambda is, this is implementing which interface? This interface. So the type is this one only. So what do you see? What do you think? If I change this one here, will it work? No, because it is expecting filtering interface implementation, and it has only one method, and its declaration is not matching with what Lambda is trying to declare. So it is a not valid type of filtering. So when it will be valid type of filtering? By this one only. So this declaration should match with this declaration. Then only we can say this Lambda is represented, or this Lambda type is this. That's what it is saying. So the type is identified about the context in which Lambda is getting used. Okay. So it validates method parameters, variables, then return statements, and everything to determine the target type of a Lambda. Now, behind the scene, how it works. So first it looks for the declaration of the method. So first thing, it will look for this one. This is the declaration of a method, that it should return a Boolean. There will be only one parameter. Okay. So the first step is done. Then identifies the target type. So then it will check? It will check if SAM is there or not. SAM is nothing but single abstract method. So Lambda you can use in the context of single abstract method only. So let's say if I have some method filter one, Lambda won't work because compiler doesn't know its target type itself. So why it is giving error? Why it is giving error is it is expecting filtering type of object, and here we pass the Lambda. Now compiler needs to know about its type with the help of the target type itself. So what compiler do? It goes here, it checks. What it checks? First thing is whether this one is matching or this one matching. So this one is matching with the Lambda that we given. Then it checks whether this interface has a single abstract method or not. So it is not having. So that's why it is giving error, and it is saying target type of this expression must be a functional interface. What is functional interface? A functional interface is an interface which have only one abstract method. Now, then the description of the abstract method, and then the actual argument of method needs to match the above level description event throw clause to. So basically at high level, what behind the scene is happening, this complete method is matched with the Lambda implementation or Lambda expression. Same thing, same number of parameters should be there. It's even the same type. How the comparison will work? Only if this is an functional interface. If Lambda can be used for the implementation of a functional interface only. Functional interface is nothing but an interface which is having only one abstract method. So if you see, this is the example. There is one Lambda expression and there is one object. So how we can fix it? So what we're going to do here is we're just going to paste it. So if you see, it is giving error. What it is saying? It is saying target type of this expression must be in functional interface. So what I explained right now is Lambda expression can be used only in the context of functional interface, because compiler need to know its type, and its type can only be determined when it is an functional interface, because there needs to have only one single abstract method. So all these checks needs to be ticked. Only then compiler will know the target type of this lambda expression. So object itself is not a interface, it is a class. How we can correct it? Runnable is one of the interface which is having only single abstract method. So if you see, so for this single abstract method, this is the lambda, and what is the type of this lambda is runnable right now. If you want to change it, you can change it. You can change to some other single abstract method interface also. That is the functional interface also. In that case, so let's say if I create this one filtering, let me do one thing, not filtering. So let me do demo, or just give some proper name, type check interface. And what I'm going to do here is I'm going to have return type as void, nothing, and then this one. So this is also a valid functional interface because it has only one abstract method. And now what I can do is I can have the same code with this one. So see, here its type is runnable, here its type is type check. So based on the context, compiler decides it type, that in which context this lambda is used. So here it is used on runnable context, it is of type runnable, and here it is used on type check. Okay, cool. There is two more points. The second last point is type inference. So what is type inference? Type inference is nothing but inference. What is inference means? Inference means is to get hint from something. So compiler get hint from the context, from the functional interface, this one declaration and all, to get the target type of a lambda. Okay, so that's what it is written here. Java compiler deduces what functional interface to associate with a lambda expression from its surrounding context. Okay, so the Java compiler basically finds out or get clue about which functional interface to associate with a lambda expression by going through the surrounding context level. Okay, meaning it can also deduce an appropriate signature for the lambda because the functional descriptor is available through the target type. The benefit is that the compiler has access to the type of the parameter of a lambda expression, so that it can be omitted in the lambda syntax. So that's what I explained now. So once this lambda is having a target type, now compiler knows this target type of this lambda. So you can omit this int also. You can add it or you can remove it. Because now the compiler has some hint about what is the target type of this lambda. You can omit the type of the parameter itself. Now, the last point, restriction. If we are using lambda, what are the restriction we need to keep in mind? So first thing is local memory restriction. So if you are using lambda, and if you are trying to access any local memory, so here what I'm doing, I'm creating a runnable, and here I'm passing lambda implementation of a run method, and here I'm using a local variable count, and I'm incrementing it. So what error it will show? Let's see. Let's go to code to check whether it shows some error. If you see, it is saying something. Local variable count defined in an enclosing scope must be final or effectively final. So what it's saying, it needs to be final. If you want to use this local variable, it needs to be final. So if you are just using it, there is no issue. But if you are modifying it, then it is the issue. What Lambda is saying, you should treat this local variable as a final and effectively final. Okay, why? Again, this why comes. Why this restriction is there? Because local variables lives on stack frames. So once function is ended, stack frame is destroyed. So if we see it, consider this example. Sorry. Cool. So what I'm doing, I have a method in which I have a local variable 5. And now I'm creating a thread inside which I'm using this 5. basically num. So what will happen? So basically, there will be one stack frame, okay, where this num is stored. So when I'm using this num, okay, and since it is running on different thread, so there will be one more call stack will be there with the value 5 only, but it will be a copy, not the reference one, okay, or not the memory address. It will, what it will do, it will take a snapshot. So once we are using inside a lambda this num, it will check what is the current value of this num variable. It will snapshot it, save it in a call stack, and give it to a thread. What restriction we have when we are using lambda? We cannot modify the local variable. Why? Because local variable lives on stack. So it might be a case when we are having one method which is running on completely different stack using thread or something else, and it is using its parent method variable. In that case, we cannot allow to modify it because it might be possible at the time we are modifying this num in the different thread itself. It might be possible that parent thread completed its execution before the child one. So there is no use. There will be an issue of reading and free memory itself. So why this restriction is there is because local variables lives on stack frames. Once function is ended, the stack frame is destroyed. So if lambda use this variable, then it will be an issue. So now this is consider this example, and let's go with flow. So what happens internally? Now num lives on the stack of test method. Okay. But lambda runs on another thread. Maybe after test finishes. So if lambda tries to access num directly, it will be trying to read from memory that already gone, a risky reference. Okay. That's why Java copies the value of num into lambda. That's why instead of this thread or lambda, instead of directly pointing to num, it just takes a snapshot version of the variable of the local variable and keeps in their own stack. Okay. So because Java copies the value at the moment the lambda is created to be safe from inconsistency and thread safety and promote immutability. That's why. Okay. So you can use local variables inside lambdas only if they are final or effectively final. Now, the last one, the closure. What is closure means? So if you are familiar with JavaScript and some other languages, there already we have concept of closures and all. So closures is nothing but a function which can remember or use its outer variable itself, even after the outer function has finished running. Okay, that is closure. So what it is, so here, this is what closure is. So what it is saying, a closure is something where a function, this thread function, which is running on completely separate stack itself, can use its outer variables, outer accessible variable, which is this one, test 5 variables, even after the first one, that this test one has completed its execution. But that is not the case here in Java. We see why. Why? Because if we give in that way of access, that kind of access, it might be possible we are pointing to a memory address where this num is having value as 5, but till the moment we are pointing it, so let's say this test execution is ended, now this num is destroyed. Now some other variables are printed there. So let's say some user's password is printed at that memory location. So at what will happen? By mistake, we end up having that user password itself instead of the number 5. So that is the risky reference. We cannot point to the memory itself. That's why In Lambda, we take a snapshot version of the variable itself. And that's why when we are changing the variable value here, like a count plus plus, won't work because it might be possible this count variable itself doesn't exist in the outer function. Okay. But closure says it should access it. But in Java, we have a restriction. We cannot let or modify the local variables. The instance and static one, you can do it, okay, because they lives in object memory, in heap memory. So that is completely fine, but not with the local variables. Cool, guys. So we talked a lot about lambdas, what it is, how it helps in writing clean and concise codes, what is parameterizing the behavior, what is the benefit. So the simple benefit is that you instead of deciding yourself what in which way your function will behave, let the caller of that method pass the behavior itself, like, okay, this is the way you need to behave on this data set. That will be the better way. That is nothing but the parameterizing the behavior. That is one of the feature you can get leverage from functional programming. Then we talk about some examples. There is no actually a functionality change, only representation wise. Before Java 8, you cannot pass the function to a certain method. Okay? That was not there before Java 8. Cool. Now we talk about lambda expression is divided into three parts. First part is list of parameters, an arrow, and then the body of the lambda. And then if you know about the statement and expression, then you can understand when and when not you should return or print or use lambda expression. Okay. What is the valid lambda expression? You can then only understand it. Then we talked about type checking. So everything in Java has some type to it, whether it is variable, object, or something else. So the lambda should also have the type check. How compiler knows its type? Compiler knows its type by using the surrounding context, by the functional interfaces. They compare the functional interface method declaration with the lambda expression. Then they identify, okay, these are all are matching, and there are a bunch of checklists you need to perform. Like the interface should be functional interface. Functional interface is nothing but a interface which is having single abstract method, and then a declaration should match and bunch of other stuffs. In that way, compiler knows what is the type of the lambda. Once it knows the type of the lambda, then there is no need to have the type of the there is no need to pass the type of the parameter. You can omit that. You can have it also. You can omit that also. There is no harm in. Then we talked about in type inference. Type inference. Inference nothing but is nothing but to have some clue about something. So Java has some clue about the lambda expression type through its surrounding or context, and then by comparing all the declaration and other stuffs. Okay. Then we talk about restriction, where we cannot what all things we cannot do with lambda expression. So that is, we cannot modify a local variable. We talk about why we cannot modify is because of something stack frames issue. Cool. Then we talk about in last what is closure in other programming languages. What is the restriction in terms of Java? Why the restriction is we already talked about. Cool, guys. At high level, this is what lambda is. Go play around it with it. Anywhere you find an interface which has single abstract method, you can definitely write an lambda expression there. Use it to full extent. Do comment below if you get any issue with the series, if you have some doubt, or you want me to explain certain thing again. I'm happy to help you out. Cool. So till then, do like, subscribe, and comment. Please share with your colleagues and batchmates and stay tuned for more videos. Thank you guys. Bye bye. Take care.